In 2003, a Fortune 500 aerospace company started buying back its own aircraft. Not to refurbish, not to resell, to take them to an Arizona boneyard and grind them into pieces small enough to burn. The program cost the manufacturer an estimated $1 billion over its lifetime, and the aircraft they were destroying was the most advanced business turboprop of its era. This is the Beechcraft Starship. Two numbers to start with. 53. That is how many Beechcraft Starships were built between the first prototype flight in 1986 and the closure of the production line in 1995. And $1 billion. That is the widely cited estimate for what the entire Starship program eventually cost Beechcraft and its parent company Raytheon. When you include the initial development spend, the marketing subsidies, the eventual fleet buyback, and the write-down of unique to Starship parts inventory, the billion is an estimate. The actual final figure was never publicly released, and different sources put it somewhere between 300 million on the low end and well over $1 billion once every write-off is counted. But the direction is clear. This was a genuine commercial catastrophe for a company that, until the Starship, had spent decades quietly dominating the executive turboprop market with the Beechcraft King Air. Which raises a question that aviation people have been arguing about for 30 years, generally at hangar coffee bars, generally with strong opinions on both sides. Was the Starship a genius idea that arrived in the wrong decade, or was it simply a bad business decision dressed up in beautiful carbon fiber? To answer that fairly, we have to go back to where this whole thing started, which is not with Burt Rutan, contrary to popular assumption. The Beech Aircraft Corporation of Wichita, Kansas was founded in 1932 and by the 1970s had built its reputation on one aircraft in particular, the King Air. Big cabin, twin turboprops, workhorse of the American executive transport market, well loved by corporate flight departments across the country. The problem, as Beechcraft saw it in 1979, was that the King Air 200 was already 15 years old as a design, and every one of its major competitors was catching up. So Beechcraft started thinking about a successor, not another King Air, a completely new aircraft that would give them another 20 or 30 years of market dominance in the executive turboprop segment before somebody else came along. The King Air had made Beechcraft comfortable. Comfortable is a dangerous place to be in aviation because the next competitor is always designing something ambitious out of a hangar in California. The internal project designation was Preliminary Design 330 or PD330, launched in 1980. Even at that early stage, the design team had made some radical decisions. Engines mounted at the rear of the aircraft to reduce cabin noise, an aft-positioned main wing to balance the lifting forces of the rear-mounted engines, and because a conventional vertical tail would have made an enormous sounding board directly behind noisy propellers, vertical stabilizer function assigned to little rudder-equipped fins at the wingtips. Beechcraft called those tip sails. All of this was on the drawing board before Burt Rutan was even involved. Rutan came later, and he came for a very specific reason. The reason was that Beechcraft, for all their manufacturing experience, had never actually built a composite aircraft. In 1982, Beechcraft contracted Rutan's Scaled Composites of Mojave, California, to design, build, and test fly a proof-of-concept prototype that would validate the fundamental aerodynamics of the PD330 concept. Rutan is the American aerospace designer who had already made his name in the 70s and 80s, designing the composite Long-Easy home-built canard aircraft, and would later go on to design Spaceship One. If you wanted to know whether an unconventional composite canard configuration would actually work, Rutan was the man to ask. He was also the man who would tell you the honest answer, which is not always what a large corporate aerospace client wants to hear. Scaled Composites built an 85% scale flying prototype designated the Model 115. It first flew in late August 1983, and within its first 35 days on the wing, it logged 100 hours of flight test time. The Model 115 validated the fundamental configuration and delivered enough performance data for Beechcraft to commit to full-scale production development. Rutan also holds a patent for one specific innovation, which was making the canard variable geometry meaning the forward wing could be swept forward and back during flight to optimize handling. Worth flagging clearly here. The production Starship was heavily developed by Beechcraft. The company took Rutan's proof of concept, redesigned it for pressurization, added the certified avionics, and adapted it for real-world production. Only one Model 115 was ever built. It has since been scrapped. The production aircraft is very much a Beechcraft product, refined from a Rutan starting point. What Beechcraft ended up with looked like nothing else flying anywhere. Approach a Starship on the ramp for the first time, and every instinct you have about how a business aircraft is supposed to be shaped goes out the window. The engines are on the back. The wings are in the wrong place. There is a smaller wing at the nose that looks like it should not be there. There is no vertical tail. The whole aeroplane looks like it was drawn by someone who had heard aircraft described but never actually seen one. There is a reason for every one of those design choices, and each one was defensible in isolation. The two rear-mounted pusher turboprops keep engine noise behind the pressurized cabin. The forward canard provides lift and stall protection. Because the canard stalls before the main wing does, the nose drops first, the aircraft accelerates, and normal flight resumes. It is essentially impossible to spin. The tip sails at the wingtips do the job of a vertical tail. The variable sweep canard adjusts handling across the speed envelope. Every design choice was rational. The trouble was that put all of those rational choices together on one aircraft, and the finished object looked like it had arrived from the wrong century, which, depending on your generation, was either 200 years in the future or somewhere in 1950s science fiction. Business aircraft customers, as it turned out, were not really in the market for either. They wanted something that looked like the thing they had bought before, only newer. What Beechcraft gave them was an aircraft that looked like an escaped concept sketch. But the visual weirdness was only the second most radical thing about the Starship. The first was what it was made of. In 1982, no civilian aircraft manufacturer on Earth had ever built a pressurized business aircraft primarily out of carbon fiber composite. Composites had been used on military aircraft. They had appeared on small experimental home builds like Rutan's own designs, but nobody had ever tried to certify a pressurized transport category composite aircraft with the Federal Aviation Administration. The Starship's construction used carbon graphite for primary structure, Kevlar for reinforcement in specific areas, and e-glass in others. The whole airframe was, in essence, a giant piece of composite tooling that would need to be laid up, cured, and inspected using techniques the aviation industry had never really used before at production scale. This was ambitious. In fact, it was borderline reckless for a company betting its next-generation product on it. The upside, when it worked, was significant. Composite structures are lighter than aluminium of equivalent strength. They do not corrode, they do not fatigue in the same way, and they can be molded into complex aerodynamic shapes that would be impossible to fabricate in metal. The downside was that Beechcraft was learning the manufacturing process at the same time as they were trying to run production. Tooling that would normally be developed on prototypes had to be built for production use from the outset because composite manufacturing does not tolerate the trial and error iteration that riveting sheets of aluminium happens to permit. Every one of those complications ended up on the cost side of the ledger. The Beechcraft workforce, most of whom had spent careers riveting aluminium, had to be retrained on carbon fiber layup. The tooling investment was enormous. Curing schedules had to be perfect or the parts came out weak. And every one of those problems was being solved during production, on parts that would eventually leave the factory attached to paying customers. And behind the airframe were two engines mounted in the strangest place Beechcraft had ever put them. The two engines were Pratt & Whitney Canada, PT667. A turboprops, 1,200 shaft horsepower each, 2,400 combined, driving 104-inch 5-blade Macaulay propellers mounted at the rear of the aircraft in pusher configuration behind the main wing. The theoretical advantage of the pusher layout was cabin quiet. The propellers were physically further from the passengers, and the propeller tip vortices did not slam directly into the side of the fuselage the way they do with conventional wing-mounted engines. In practice, the pusher props also had to operate in the turbulent air coming off the main wing, which made their external noise noticeably choppier and more raucous than a conventional layout would have produced. Passengers loved the cabin. People standing on the ramp had opinions, most of them involving the phrase, "What is that noise?" The Starship's rear-mounted propeller howl was one of the distinctive sounds of 1990s business aviation, largely because everyone within a mile of the airport knew when one was leaving. Inside the cockpit, the Starship had the first all-glass panel ever certified in civilian general aviation, a 14-tube Rockwell Collins Prolene 4 avionics management system. Traditional round instrument dials replaced with computer displays. This was in 1988. The Cirrus SR-22, which brought glass cockpits into small general aviation as normal equipment, would not appear for another 13 years. And what was it actually like to fly? By every account from the pilots who flew it, remarkably stable, remarkably quiet in the cabin, and remarkably comfortable. Handling was benign. The stall behavior was, as promised, effectively impossible to spin. The performance numbers, though, were where things started to go sideways. Maximum cruise around 324 knots at 25,000 feet. Maximum speed 335 knots. Range about 1,369 nautical miles. Service ceiling 41,000 feet. Numbers that looked reasonable on paper, but comparing them to the competition told a different story. And the competition was where the whole business case started to unravel. The Starship left Beechcraft's drawing board as a lean, efficient composite design that would outperform the King Air on speed and match it on economics. The Starship that ultimately rolled off the production line in 1988 was substantially heavier than the original concept. FAA certification requirements pushed the empty weight up as Beechcraft added structural margins to satisfy regulators dealing with a composite pressurized aircraft for the first time. Basic empty weight came out around 10,085 pounds, maximum takeoff weight 14,900, useful load 4,525. Every extra pound trimmed efficiency, and by the time the certification process ended, some of the aerodynamic advantages of the composite canard concept had been quietly cancelled out by the extra weight the FAA had insisted on. The list price in 1989 was $3.9 million for the initial Model 2000. Later, $3.9 to $4.7 million for the improved Model 2000A. To put that in context, a Cessna Citation 5-jet cost about the same money in 1989 and cruised 89 knots faster. A Lear 31 was similar money and 124 knots faster. A Piper Cheyenne turboprop cost $1 million less and was also faster. And a proven, well-understood King Air B200 from Beechcraft's own product line was cheaper, more spacious internally, and had a maintenance network at every regional airport in America, which meant Beechcraft was asking business aircraft customers to spend jet money on something that looked strange, flew slower than the jets, and cost more than the aircraft it was designed to replace. The Starship was competing, in effect, with itself. And the King Air was winning. For a customer looking at a spreadsheet, it was a very short conversation. Beechcraft's sales team spent the late 1980s and early 1990s trying to convince corporate flight departments to buy the future rather than the past. The corporate flight departments looked at the Starship, looked at the King Air, looked at the numbers, and bought the King Air. Total production over the entire 7-year run came to 53 aircraft. And of that 53, only a handful were outright sold. The majority ended up being leased by Raytheon, Beechcraft's parent company, to keep the numbers moving and to seed the market with visible operating examples. In parallel, aviation entered a nasty recession at the end of 1989. Exactly as the Starship was arriving to market, corporate aviation departments cut spending. Even conventional aircraft designs from established manufacturers with excellent track records struggled to move that year. An unconventional multi-million-dollar composite From a company still learning how to build composites was an impossible sell in that environment. Beechcraft ended production in 1995 with 53 aircraft on the books and a lot of red ink. Then, in 2003, Raytheon made a decision that turned an already difficult story into a genuinely strange one. Citing the prohibitive cost of supporting the small in-service fleet, Raytheon announced they would recall every leased Starship, buy back as many privately owned examples as possible, ferry the entire lot to the Evergreen Air Center boneyard at Marana in the Arizona desert, and destroy them. Most of the aircraft were physically ground up and incinerated. A small number were donated to museums, which is the kind of decision that most aircraft manufacturers spend enormous PR effort avoiding, because deliberately destroying your own product does not exactly reassure future customers about long-term support of anything else you build. What Raytheon perhaps did not anticipate was that some Starship owners would flatly refuse to sell. The owners who refused. The most famous of these is Robert Scherer, owner of Starship NC-51, who told the Smithsonian in a memorable quote borrowed from the National Rifle Association, "From my cold, dead hands will Raytheon get this airplane." Scherer went further than just refusing to sell. In 2004, when Raytheon was liquidating its remaining Starship parts inventory, Scherer bought 12 semi-trailers worth of parts, reportedly valued by Raytheon at $38 million, for a small fraction of that number. Which means the private community of surviving Starship owners now has a parts supply that will keep the surviving airframes flying for years yet. Scherer's Starship went on to serve as the primary chase plane for Scaled Composites' Spaceship One flights, Virgin Atlantic Global Flyer, the X-37, and Virgin Galactic's White Knight II, a Beechcraft Starship chasing Spaceship One. There is a certain circular poetry to that. Today, roughly 5 Starships remain airworthy. Another 7 or so are preserved in museums, and the rest were destroyed. Brothers Raj and Suresh Narayanan operate 2 working examples out of Addison Airport near Dallas through their business Aerospace Quality Research and Development. Additional flying examples are based in Colorado, Oklahoma, and Germany. Ownership of a 6th potentially airworthy example in Mexico is unclear, which is a very Starship sort of status. It is not a huge fleet, but it is a determined one, which leaves the honest question we opened with. Was the Starship really a billion-dollar flop? 2 things can be true at the same time about the Beechcraft Starship, and both of them usually are. First, it was a commercial disaster. 53 built, most leased, not sold, fleet destroyed by the manufacturer, estimated total program cost approaching $1 billion once you add the initial $300 million plus in development, the marketing and lease subsidies through the 1990s, the buyback program, the parts inventory write-down, and the ongoing support commitments Raytheon eventually decided they could no longer honor. By every conventional metric, the Starship failed. 53 units against tens of thousands of King Airs is not close. It is a rout. Second, the Starship was a technical success at almost every level of engineering that mattered. It was the first pressurized composite business aircraft to earn FAA certification, the first civilian aircraft with a fully certified all-glass cockpit and integrated flight management system, the first certificated Canard business aircraft. It flew well. It was stable, quiet, and impossible to spin. Every one of the technologies that made it commercially difficult in 1988, composite construction, glass cockpits, unconventional aerodynamic layouts, look perfectly reasonable in 2026 because subsequent aircraft proved they worked. The Cirrus SR-22 mainstreamed the composite airframe. Every modern airliner has a glass cockpit. Rutan's own Piaggio P180 Avanti Canard pusher is still in production. The honest reading is that the Starship was not a bad aeroplane. It was an aeroplane whose technology, development costs, and market arrived in the wrong combination at the wrong time. Beechcraft asked business aviation customers to be brave in 1988, at a time when business aviation customers really wanted to be sensible. Every reason the Starship failed commercially was, in isolation, a reasonable business decision by a reasonable buyer. And every reason it looked strange, expensive, or unconventional would look completely different if the same aircraft were launched today, which is why Robert Scherer and a handful of other owners still fly them. Not because they are cheap to run, and not because they are practical business tools in 2026, but because they are arguably the most interesting business aircraft ever put into serial production, and one that quietly demonstrated the future of general aviation about 15 years before general aviation was ready to buy it. So, if you enjoyed this, go watch our deep dive on the Piaggio P180 Avanti, the canard pusher that survived. Same design school, different fate. And tell us, would you fly a Starship if you could? Subscribe for more like this.